Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about wasted biogas potential. So let's dive right into it. Now, what's the logic behind it? The logic is very simple because all biomatter is basically more or less is a very ludicrously long chain of carbon and hydrogens. They generally break down, and that's what we call biodegradable. Now whenever that happens, it gives off gases, a lot of gases. Now you may be very lucky, you may only get water vapor and carbon dioxide, but generally you will still get methane. Now when you do it inside a device, let's say a biodigester, where you are removing oxygen or limiting the oxygen concentration, you will improve biogas yield, meaning the methane concentration, basically methane per part carbon dioxide will go up, so you will have a lot of methane. That's what we call biogas. Now main component of biogas is methane, which is a fuel, meaning it's flat out straight up a normal fuel. We run our world primarily on hydrocarbons, for example propane, butane, ethane, which generally goes in your cooking gas, heavier chains of petrol, diesel, things of that nature. They are still hydrocarbon, they are still hydrocarbon fuel. This is the same thing. CH4 is still hydrocarbon system, and it's surprisingly efficient, meaning every time you burn it, you only get one molecule of carbon dioxide and you get 4 water vapor. So it does have a lot of oomph to it. And what about the byproduct? Whenever you are doing something, you're always getting some byproduct. Now here's the interesting part. The byproduct, basically the biomanure you're getting out of it, it's one of the best biofeed for fertilizer industry, meaning again, the biomanure, you can directly use it in fields if you want to, but generally it's not recommended. It's only recommended once in a while if you want to quote unquote bulk recharge your land. Generally you're supposed to send it to composting department. That composting department will compost it and properly analyze it, because depending on the fuel source, basically if it was raw vegetables, if it was some sort of processed food, or is some sort of tree and all that jazz, you will have different outcomes. So it does require a bit of balancing. You're not supposed to biomanure and just tada, it's not done yet. It still requires some processing. But when you do that, you start this puppy and properly compost this one, you will get some really high quality products, meaning the product that is cheaper and makes you put a lot of money while recharging the soil. So it's awesome. So be mindful, you're getting fuel and you're getting fertilizer. Awesome. So bio-waste is the output of life itself. It's not something that it's a raw stock that you will run out of it. This is why it's classified as a renewable resource, meaning it's never gonna run out. For example, as long as human exists, that inherently means we're gonna have food. That inherently, because of the ludicrously large number of people we have, around 6 to 8 billion, we're gonna have a lot of food waste. And even if you remove food waste, let's say tomorrow we become awesome with that. Let's say we no longer have food waste, but we still have waste that is coming out of our belly. That's still gonna be there, and that's gonna be there in every single livestock. Every single living creature has that. Heck, if you take a tree and it's just let's say lightning strikes it, which does happen, and it starts to rot, what happens? It's still giving off methane, still giving off carbon dioxide. So it's nature's cycle. You don't have to worry about it. So as long as there is life, meaning people will plant crops, meaning inherently you have a feedstock for it. You will never run out of it. And where's the energy coming off? If I'm saying it's a complete cycle, that inherently means it's what is it, free energy? No, because the energy is originally coming from solar energy, meaning the photosynthesis is the core behind this. Basically, what does photosynthesis do? In a simplest dumbed down manner, it takes energy from the sun, takes carbon dioxide from the atmosphere, take that carbon, takes water from the roots, and eat the oxygen, take the carbon and hydrogen, make hydrocarbons. That's why plant actually grow. Think of it this way, how the heck you can plant something like a tree and you grow it on a land is not become lighter. Let's say it's a plot of land and land is not getting lighter, but where the heck this 100-ton tree came from? It came from atmospheric carbon, literally. So that's why forests are classified as carbon soaps. So that's what is the fuel cycle of it. You're just using it differently. Again, same thing, same tree, you bury it underground for thousands of years, you have coal. Again, problem with that is when you're talking about fossil fuel are specific carbon that our nature sequestered, meaning just let's delete this puppy, let's just forget about it. Now the reason why nature did that is basically there is a very fine-tuned balance around it, and not balance as in the planet needs this sort of balance, because planet is just a rock. The balance is for the life form on it. So nature inherently created a self-limiting factor where it's thou shall sequester excess carbon dioxide. So that's the logic behind it. So if you are using methane as a system, you are not polluting the atmosphere, you're not creating something, you are just using solar energy with extra steps, nothing more than that. Now you have to understand the methane aspect of it, because the CH4 is literal poison for our atmosphere, because methane is a great greenhouse gas effect, meaning these are generally the top greenhouse emission gases. Now you will notice CO2, everybody knows about it. You will know nitrous oxide, again it's a smaller component, but you get that point. You have SF6, which are generally used in substations and all that jazz. Those are also used in other industrial process. They are greenhouse, right? Then why the heck there is CH4 out there? Because I specified CH4 is a fuel, so nobody's like leaving it like just fuel, let it go. Nobody's doing that. So how the heck this is happening? This is happening because of all the biodigestion that's happening around the world. For example, every cow dung, every single time basically we are pooping, it's like every living creature is creating that. And methane, in terms of parts, basically how many molecule of methane is present per part of carbon dioxide, is very low. It's like 200 molecule versus 1 molecule. But the consequence of that is ludicrous, meaning this puppy, even though it's in terms of concentration is very low, it can bitch slap carbon dioxide. For example, if you take 100 years of lifespan, basically, because this puppy is reactive, it will break down due to one way or the another. This is not long lasting. CO2 is ludicrously long lasting. So you take this methane for 100 years, this will literally outperform CO2 in terms of heat retention by 28 or 34 times factor, meaning if you extrapolate the data, many times you will hear people say, talk about like, you know, it's 1,000 times more potent. Yeah, it's true, because while it is true, it will break down, but in the early years, basically, let's say you released methane into the atmosphere, let's say 2020, it will cook the planet to nth degree just in 50 years, let alone what will happen in 100 years. Like it will cook at that, and yeah, after that again it will break down. But here's the deal, what will happen after that? The whatever remainder is left, CO2 can handle that. So fundamentally it's very brutal. That's why it's almost at the same playing field as methane. We have to get this puppy under control, otherwise we're gonna cook ourselves and we will not even notice it, because majority of the people think about carbon dioxide while it is a big bad boy. This puppy is a silent puppy, so we have to pay attention to that. It is very seriously poisonous to our atmosphere. Like this puppy is like very, very serious. Now, to give you a context of how serious this is, like if every time where people build biogas generation plants, they have a scenario like mechanical malfunction happens or overproduction happens, one way or the other things happen where you have too much methane. It's much more environmentally friendly to just take that methane and burn that puppy. But under no circumstances methane should be ever exposed to the atmosphere. That should be like, nope. No, not at all. And that's why our landfills are such a big disaster, because they are leaking methane, which is really, really bad. Like it would be far more efficient for our atmosphere, just like we take all the methane from landfills and we just burn that puppy, just burn it, like don't even convert it into a useful electricity, just go YOLO on it, still would be better for our atmosphere. So that's why it's very, very desirable to break that puppy into CO2. It is compulsory, we cannot ignore it. And what about the fresh CO2 you are adding by, like, you know, burning CH4? It will, because it's a closed cycle, meaning you have plants. Plant is generally used for all biofeedstocks one way or the other. Either you eat it or something else eats it and then you eat that thing. It's more or less a complete cycle. What happens at the other end? Once, you know, the apex predator dies, what happens then? The apex predator, in our case, nature reclaims it. How does it reclaim it? Using microorganism. So one way or the other, it's completely cycle. And that when microorganism is breaking down any living matter, what is releasing? It's releasing carbon into the atmosphere. Now why it's doing that? So other generation, meaning the next generations of plant have something to feed on. Because if that did not happen, let's say every time something dies, that CO2 is completely sequestered, like how fossil fuels are. It's like, but efficiency is very high. It's like, you know, sequester 100% of it, we're gonna run out of carbon dioxide very quickly. So there is a balance to it. So that's why it's a completely closed loop, which is using solar energy. You don't have to think about it, but we have to take this puppy down. Like, I did not actually understood like significance of it. It's like if we leak 100 tons, it's equivalent to leaking million tons of CO2. I'm like, how the heck it's that far apart? It is. That's why, like, whenever you go to basically any sort of climate you know, accords, you will find that methane is one of very serious thing, and it has to be tackled. It's not optional. We have to sort this puppy out. Now what about the economy? Now I have talked a lot about, like, Indian government tried a lot to get biogas plants. Heck, you can buy something this small in Karnataka and like basically South Indian states, and they do work. There are things, they do work. India tried that's like as early as like 1990s. We tried a lot into this, but problem was biogas as an industry does not recommend small scales, meaning at small scale output is always disappointing. Yes, this puppy can, like, you know, cook your run your gas stove for sometimes. Awesome. Here's the deal. You have to feed almost 1 week worth of you know, garbage to get 1 day of cooking gas. While it is awesome, but imagine instead of doing this, you had like whole you know, basically district kind of biogas. Now you're talking some serious biogas production. That's the whole thing. At small scale, it does not make sense. At small scale, even like farmers who are using like, few cows, it did not make any sense. Like people have tried it. This is one of those things that thousands of plants have been made, but majority of them failed. Not failed as in like they did not work. It's like people were like, wait a minute, that's it, that's all it gave me. So output was very disappointing. Now the primary reason for that is it really benefits from economy of scale. For example, if you're making a chamber, the bigger the chamber you make, the cheaper it gets. It does not matter which metal you are using, it's always the same. Be it rocket engine, where it's like you're using a super expensive alloys like lithium aluminum alloy or carbon fiber, bigger you make it, the surface area to volume goes down by the ratio of cubes, meaning every meter square you are adding in terms of surface area, you are getting cube of it. So it's ludicrously more efficient to make large tanks. The larger the tank you make it, even if you have to make the walls thicker, per liter it's cheaper. So that benefits it. And because you are talking about large money pools, you can do with things that allow you to boost output. For example, this puppy, let's say there was 50% potential to make methane. This will only get you 20-25%. Same thing here, it's a bit better because it's underground, so temperature might be a little bit warmer, but it will not give you too much. When you are talking about like a large plant which has like large feedstock, now you can add things to it. For example, heaters. Like why the heck you need a heater? Well, at certain temperature, like there is a certain temperature, and depending on your feedstock, it could be as low as like 30 degrees Celsius or 40 degrees Celsius. There is like a certain temperature, like you will do analysis on that. At that temperature, it's going to give you the maximum output. So you want that heater there just to balance it out. Then you need mixer, so things are breaking down, because you really don't want chunky material there. You want it to be turned into mush. Basically, the better the mush, the better the output. You want mixer. Again, that does add cost. It's not economical to add those sort of thing in this tiny things, but huge power plant, awesome. Then CO2 and H2, basically sulfide scrubbers. Now these scrubbers have been used as small scale as like 10 kilowatt power plants, but they are not very efficient. Now you're talking about something that deals with megawatt. Now you're talking about scrubbers that cleans the output to such an extent that these basically CO2 is not that dangerous to your engine, but hydrogen sulfide is really not pleasurable thing to deal with. But you get that point. Like at large scale, many things make sense. Like at large, like a family house, you cannot gonna have a chopper that's gonna chop your vegetables and make a perfect pulp. But in a large scale, where you are dealing with, let's say, a whole vegetable market, where you have almost few tons, almost 10 tons of vegetable, then investing into a chopper that's gonna chop your vegetables finely and make a good pulp is affordable. So that's why biogas industry fundamentally loves large scale products. The bigger the scale, the more GG output happens, and the more GG output, the more economical it becomes. So it's a self-fulfilling loop. Smaller ones, good for experiment, good for blah blah blah, but like reality, people try this and they're like, yeah, I'm disappointed in that, and I cannot blame them. It's like it fundamentally is like it's gonna do this and that. Is like when you're like, yeah, it does give me fertilizer, but I need gas, because I bought, like, again, many people wanted to reduce their LPG bills. They wanted to use this. Did not work the way they expected it to. So that's the whole thing. But now imagine the same thing dealing with a large scale where it's dealing from a restaurant output, which is like a very high throughput. Now you're talking serious amount of gas. So that's the economic aspect of it. It loves large scale. At small scale, it's like almost pointless to do. So what can we do? Well, it's not optional. You have to be very mindful of that. We must reduce CH4 emissions. It's not optional, it is compulsory. Now, it also has a secondary benefit, because if you are dealing with a megaton scale objects, you are also talking about very large amount of biofertilizer feedstock that will go into fertilizer industry. Now that industry will also reduce its requirement on chemical fertilizer. Benefit of that is, like, again, it will still need to balance it out. Sometimes you may have, hey, nitrogen composition is like a bit low, let's add it, or sulfur, phosphor, whatever have you. Like there is a whole industry and science behind it, but you get the point. Like it will still require some chemical love to it, but compared to hundreds of tons, it will be like few tons. So that's surprising. Again, you are reducing carbon footprint right there. And what about the fuel that you're getting, the gas, the biogas? Here's the thing. If you can filter this puppy out and properly compress it, like there are plants to dealing with that, but again, it only makes sense on large scale. It is best fuel, meaning it's one of those renewable resources that you do not have to need PhD to use it. For example, solar panels, they work, they are amazing. They are useless. Like you need to take the solar panel, feed that power to battery, then feed that power to an inverter, then you use it. That's way too many steps. Here's the deal. How do you do with biogas? Once you have filtered it out, you store it. exactly how you store LPG. You do not need another PhD on that. It's just like exactly. And in case of India, we have CNG network in Delhi. It's the same thing. CNG is compressed natural gas, which is generally majority of it is methane. When you're talking about basically heavier gases we use for our cooking, those are propane and butane. But when you're talking about CNG, vehicle fuel, that's methane. So we already know how to deal with that. There are generators from every manufacturer, every large manufacturer you can buy. Some of time they will modify it themselves, or they will sell you a kit to modify this sort of vehicle so it can work on methane. It does not require anything, so it will work for vehicles. Surprisingly, also you do not have to change the whole ecosystem. Does not need to worry about lithium and all that jazz. Like just go, don't worry too much about it. And moderate generator will work. So normal generator output. So what does that mean? That simply means if you want to do what we call grid tied generators, those are expensive units. Again, if you can just buy it, like if you can call up CAT and it's like, hey bro, we need a biogas generator, they're like, I got you fam. That's awesome. Rather than like, yeah, we need this and this and this and this, like from these rare manufacturers. You really don't want that. And if what happens after the outputs puppy of this, like let's say this is only going to give you 20 to 30% of maximum potential that the fuel has, but you can still have CHP, meaning collective heat and power, and that point combined heat and power. At that point you can use that heat for other things. For example, in case of India, that heat can go into what we call absorption chiller, meaning you're running a refrigerator from the waste heat of the generator. At that point in time, you have a refrigerator that is working every time you are running this puppy on, and you don't have to run the electrical load of a compressor. You're getting a ice for free. In case of winter places, again you have heat, just use it. So you get that point. Like there is a tremendous amount of efficiency, and heck, if you only want electricity, you can still add basically a Stirling engine and get some energy out of it. So your total efficiency would be high, or you can go even higher if you have the money and scale. The largest scale I have seen biogas is 20 megawatt. Yes, I have provided video down below. It's generally running on landfill. Yes, landfill gives up that much gas, and they are using generators. While here's the deal, they can double their output without doing too much if they go from basically this sort of combustion engine to solid oxide fuel cell, like a made by company known as Boom Energy. It does work, but it does expand your cost a lot, not only of inverter cost, fuel cell, like it does add cost. But again, if the electricity prices are good enough, you can do that, and that point efficiency boost will make you more profit. So use wise, this is one of the things that you don't have to worry about. Like think of this, let's say you have a country that is like solar is like taking the bulk load, you have offshore wind that is taking care of the secondary loads, then you have hydropower. Like I'm talking about everything that India already has. All these things are giving you bulk load, but you still, that's some time that you need some extra power source. Biogas to the rescue. You can store it. Like during the days that is like, solar is like, I got this fam. During the windy times where it's like wind is like, I got this fam. You do not do anything with the biogas. You just store it, because we know how to store it. We know how to store like months worth of supply of this. You can keep just storing it. And then it's like, oh, today is that bad day, we don't have wind, we don't have solar. Biogas is like, I got this one. Now again, we do not have enough biogas to like run our world on it, but we have enough that if you add solar and wind and hydro, we got this. We got this right now. So what we can expect in the future, one of these things you have to understand, we have not even utilized the 1% potential of it. Meaning if there was 1 gigawatt, we had barely extracted 1 megawatt out of it. So reality is we have to do this, because global warming will not be stopped. Because again, even if let's say magically in next 70 to 80 years we have reduced our carbon footprint, but we forgot to take care of our methane output, we'll still be cooked. So we have to sort this puppy out. It has to be sorted. And one of the amazing aspect of humanity is that we have bio waste. Waste is one of those things that we're never gonna run out as long as there is life form on this planet. Be it dairy industry, be it food industry itself, we always gonna have the feedstock to create this puppy. So we're never gonna run out of the quote unquote fuel. And organic waste, as in like it's also created in wood industry, it's created in paper industry, like the many industry that creates biodegradable waste. Now be mindful, all of them will require separate digester. So even if you have a large power plant, you may have separate digester. If you want to digest basically human feces, it requires a bit different biomix compared to what a cow gut does that. So you do need different reactors if you want to do maximum efficiency, because if you mix them all of them together, you're not going to get anything. So you do need different reactors for different things. Basically, if your output is primarily food, you will have different biodigester just to dealing with food. If you have different sort of system, you will deal with that. It's a renewable resource that behaves like a chemical fuel, exactly the fuel that we know how to use, that we want to use. Basically, we turn the power on, it goes on. It's not like, oh, the sun is not shining or the wind is not blowing, you don't work. It's like exactly how we want it to. And adding it to our grid, basically green grid that every Tom, Dick and Harry is doing, it allows power management, meaning this puppy can easily act as a good peaker power plant. And it has to play a key role in our future, because again, methane poisoning is far more serious than I originally thought. And again, more than enough people is like, yeah, methane is very serious, but again, I did not know this. So you get that point. Like, I think biogas has to be utilized, because we really have to sort this puppy out before we cook our planet because of our poop. I really do not like that idea. I mean, like, if you're contaminating the planet, that makes sense. Okay, we messed up. If you're pooping, it's like, oops, that's really bad. So we really have to sort this puppy out. So this was my presentation on wasted biogas potential. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.